afternoon, everyone. Today I'm going to present you the impacts of climate change on the Gediz River Basin, Turkey. My name is Aslı Hankol, and I work as a water resources engineer at the General Directorate of State Hydraulic Works in Ankara. So here is the outline of my presentation today. I'm sorry for that. So here is the outline of my presentation today. First, I will give a short introduction, and then I will talk about the general circulation models, future climate projection, and then downscaling techniques, hydrological models, and then I will conclude my slides with the summary and conclusion. So, as we know, water resources are limited, and the results of climate change are rising temperatures, changing rainfall patterns, and water scarcity. And as a DSI, we work and we plan the water resources. There is Gediz River Basin in western part of Turkey. The basin area is approximately 17,000 kilometers square, and we wanted to project the climate for the future time period and see how the water is changing with the changing climate conditions. So there are general circulation models. These are mathematical models that represent various physical processes of the global climate system, and they include atmosphere, hydrosphere, biosphere, and ice and land surfaces. So as you can see from the right of the image, these models work as they first divide up the Earth's surface into different grids, and they solve all the mathematical equations based on those grids. In the world, around the globe, there are many models available, as you can see from the US, China, France, European models, and they all have different atmospheric resolution, and they have all different vertical levels. So when we use general circulation models, we need to actually use different models in order to reduce some uncertainty of the atmospheric models. But of course, the resources, computers, supercomputers are really difficult to find. So sometimes we can only use one model to make some climate projections. And that's what we did in Ankara. So for Gediz River Basin, we use GFDL ESM2M atmospheric models. And also, those models actually don't represent the socio-economic change, technological change, and energy and land use, and also emissions of greenhouse gases and air pollutants. Therefore, we have to use also RCP scenarios. For this model, we use IT 8.5 scenario in order to see how the climate will show us the conditions for the RCP 8.5 scenario. So, as you can see for two graphs, so the one on the left side includes the RCP scenarios. If we don't use RCP scenarios in our atmospherical models, we don't really represent the temperature very well. The right one with the blue lines, that one shows if we just use the GCM models, we cannot really show good results of the temperature. Therefore, we have to use RCP scenarios as well, and that's what we did for this project. So these models have a very coarse resolution, therefore they don't represent well for fine resolution scale studies. So what we did was there are two different downscaling techniques. One of them is statistical downscaling, and the other one is dynamical downscaling. Statistical downscaling is based on statistical relationship between large-scale climate features and hydrologic variables. And the advantage of this downscaling technique is it's computationally very simple and it produces very fast results. So, but the disadvantage is it's really uncertain if the current statistical relationships will maintain in the future time of the period. And also, it requires a long historical observed data set, which is very hard to find for countries like, for some of the countries. So we had data problem. Therefore, this downscaling technique was also not very suitable for us. The second one is dynamical downscaling. And the advantage of this model is it's based on the physical equations, physical laws, for example, the law of thermodynamics. And those are expected to hold under climate change. Therefore, such techniques are really good to use for any research studies. But the disadvantage of this technique is it's really computationally expensive and it requires a lot of time to finish the model simulations. Therefore, if you need the quick results, that's not very suitable. So what we did was we used one of the dynamically downscaling technique, WRF model, and they have different resolution. For outer domain, we use 27 kilometer by 27, and for inner domain, we use 9 kilometer by 9 kilometer. So Geddes River Basin is the one colored with orange. So, but okay, we modeled the atmospheric products, but we need also we need to see how the hydrology changes with respect to changing atmospherical conditions. Therefore, there are different hydrological models to generate stream flow data. We need to use hydrological models because for data we have gaps in existing records, and also providing a long record to establish a long-term trend. So we want to see how the trend is for a basin. Then we really need to also generate the stream flow conditions of any basin. And also estimating stream flow for ungauged areas. If we don't have any station data, we can use hydrological models to estimate the hydrology of any basin. So the hydrological models are whether you can use any hydrological models by their spatial representation. There are lumped, semi-distributed, and distributed models. And there is also, based on their process descriptions, there are conceptual and physically based hydrological models. So those are our results for Geddes River Basin. First, between the 2030 and 2040, we did atmospherical model for RCP 8.5 scenario. And these graphs actually show us how the temperature changes with respect to their spatial condition, and also the graph shows how the temperature is changing with respect to time. So we find out that there is an increase in temperature, but we cannot really call a high temperature increase for this specifically Geddes River Basin, because we actually take the average for the whole basin. But if we look at the images, we can see that some part of the basin has more critical condition based on the temperature changes, but the other part of the Geddes River Basin has low problems with the climate change, let's say. Also, we checked rainfall. So we wanted to see how the future rainfall conditions are. So Geddes River Basin, we saw actually a negative trend in Geddes River Basin, even though we saw some increase of the some areas of the Geddes River Basin. In general, there was a decrease in rainfall. So once we saw the atmospherical conditions, we needed to simulate the hydrological uh, stream flow data for the Geddes River Basin. So first, we needed topographical maps. We used SRTM data to check the elevation of the basin. Then for hydrological model simulation, we used also land surface, how the land use and land cover is changing around the basin. Then this station results show that between 2030 and 2040, 2050, how the Geddes River Basin hydrology is changing. So to summarize my presentation, even though we know that general circulation models produce good results, it actually has to include RCP scenarios. Um, but there are also different downscaling techniques, statistical and dynamical. Even though statistical downscaling might seem very comfortable, very fast, very easy, we actually should use dynamical downscaling to include their physical um, variations and also hydrological models. Even though sometimes we use only one hydrological model, it's important to use multiple to reduce any hydrological model uncertainties. So more accurate atmospheric model inputs leads to more reliable outputs for hydrological models. And with this project, actually, we saw that if we work on site projects for Turkey, we can also take any action as a general as we use such models. If we have to plan water according to the changing climate, we can have more reliable, more better results for the community as well. Thank you for listening. Any questions?
Thank you for your presentation, valuable presentation. It's really good. Just if I didn't catch the things, I have two questions. The first one, I am sorry if it didn't catch the first. Which one is the scaling did you use? Downscale for the downscaling, statistically or dynamic, or together that you used?
Okay, sorry
And the
if
second
I
question,
wasn't.
sorry. The second question is that you mentioned that the temperature is variating in that area. The one area to the other area, the basin changing the temperature. So how did you get the results? Gathering all the data, getting the average, or delivering the other parts or the regions, and then get the whole holistic result. Thank you.
Okay. Thank you for the questions. For the first question, if I wasn't very clear, sorry for that. Um, so can I go back to the slides, please? So maybe I wasn't very clear, but WRF model is using dynamically downscaling techniques. So for our project, we use WRF model. which uses dynamically downscaling. We didn't use statistical downscaling, but so weather research forecasting model, I'm sorry if I forgot to mention, this is a non-hydrostatic model, and it only does the dynamical downscaling, and it requires a long time to get any results as well. And for the second question, so these model results have actually grid size. So here I try to show that the inner domain has 9 kilometer by 9 kilometer. So for temperature, unfortunately, because you have 9 kilometer by 9 kilometer, we had to use an average one. So by using average, we got these results. But of course, to get a better result, we always have to go more finer resolution. And but yeah, so that's my answer. If I was clear enough, yeah, you are welcome.
Hello everyone, I'm Şükrü, and I'm an environmental engineer from the Republic of Turkey, Ministry of Agriculture and Forestry, General Directorate of Water Management. Welcome to our pavilion today. Today I would like to talk about some of our projects related to climate change impacts on water resources and snowmelt. Uh, Today, I would like to tell the story within two pillars. First, the climate change impacts on water resources project and the assessment of climate change impacts on snowmelt and stream flows project. To begin with, I would like to give a brief introduction about Turkey. Turkey is located in the Mediterranean basin, one of the most vulnerable regions to adverse effects of climate change. Water using sectors are the most vulnerable ones to climate change in Turkey, and Turkey is divided into 25 hydrological river basins. In some river basins, water demand could exceed the potential of the resources. So it is so important to assess the impacts of climate change on water resources in Turkey. Uh, Therefore, this brings us to our first project, which is climate change impacts on water resources projects that is conducted between 2013 and 2016. The main objectives of this project are to determine the impacts of climate change scenarios on surface and underground water bodies, and to identify the adaptation activities based on river basin districts covering whole Turkey. Uh, Let me briefly explain the methodology first. In the first part, we used three global climate models under two scenarios, which are RCP 4.5 and 8.5 scenarios. And we downscaled them to the 10 kilometer resolution by using regional climate model. After that, we conducted hydrological models. Finally, we obtained future projections of water availability. In the other parts, we made sectoral water usage projections. We use four different sectors for this part. Domestic water use, agricultural, industrial, and ecosystem water use. And after that, we created future projections of total water usage. Uh, and finally, by combining these two results, we estimated the water shortage or excesses in Turkey. Uh, After the analyzing all these data, we and running these models, we obtained 8 main climate parameters, such as temperature, precipitation, snow cover, relative humidity, pressure, and total radiation. And also, we generated 17 indices, climate indices that shows that predicts the frequency of the extreme events. The first parameter is the temperature. As a result of this study, we observed that there will be a temperature rise all over the Turkey, according to all models and the both scenarios. The temperature rise is expected to be 2 to 3.56 degrees Celsius under RCP 4.5 scenario and 4.1 to 6 Celsius degree under the RCP 8.5 scenario. And this figure shows the average temperature anomalies. As you can see in the figure, at the end of the century, there will be a significant temperature increase, and uh, especially in summer, this increase will be higher. Also, in the southeastern, and eastern parts, the increase will be higher, around 1 to 2 degrees than the other parts. And the second one is the precipitation. Over the Turkey, in general, total precipitation will decrease according to both scenarios. However, this change will vary depending on the regions and the seasons. If you look at the right bottom side, you can see on the northern parts there will be a precipitation increase. On the other hand, in the southern and the western parts, precipitation decrease is expected. So this means in some parts of Turkey will suffer from floods, while some other parts will experience the drought. And when we look at the climate indices, frost, cold days, cold nights, and cold waves will decrease in time. However, in the number of hot nights, hot days, heat waves, and summer days over 25 and 35 degrees Celsius, there will be an increase. Also, we looked at the precipitation indices. Most of the precipitation indices do not show significant changes, such as 1 day and 5 days maximum precipitation, number of consecutive wet days, days with heavy rain, and days with moderate rain. However, in the consecutive dry days, there will be an increase, significant increase, and this shows in the future the droughts can be more severe. As a result of the old gathering these data and making these analysis, we obtained a map showing water excesses and deficiencies of river basins in Turkey. So, as you can see in the map, we can say that in some parts of Turkey, there will be a water excess, especially in the northern parts, the Black Sea parts, the blue ones. On the other hand, some regions will suffer from the water shortage, like Euphrates and Tigris, Konya closed basins are the examples of them. In conclusion, for this study, average temperatures in our country will increase significantly. There will be a general decrease in total precipitation, and it will vary depending on regions. Precipitation decreases will be more in winter. Average heat waves will significantly increase, and this will rise the risk of forest fires. And also, serious water deficits is expected in the Euphrates, Tigris, and Konya closed basins. After the previous project, we determined that snow-covered areas are needed to study it more because they are highly vulnerable to climate change. So we conducted a project in Euphrates and Tigris basin because this basin, annual flow in this basin generally comes from mostly comes from the snow melting. So we completed the assessment of climate change impacts on snow melt and stream flows project between 2018 and 19. The main aim of the project is to assess the effects of climate change on snow melt-fed rivers in Upper Euphrates Basin. There are four main project steps. First, characterization of the snow-covered area and snow cover, and then the acquisition of natural flow rates, then establishing and verifying mathematical models that relate flows and the temperature and precipitation variables, and lastly, obtaining the future forecasts of snow melt and stream flows using climate projections with established models. As a result of this study, we observed that in the percentage of snow-covered areas, there will be a decrease. Also, in the number of snow-covered days, uh, we will observe a decrease again. So, and this change will be up to 55 days in some points, in some regions. And also, this we obtained this figure showing snow water equivalent projections. We also observed there will be a decrease in snow water equivalent in the future. So when we combine this result and the previous one, the decrease in snow covered days, we can say that there will be a decrease, a problem in the annual surface water potential in this area. As a result of the study, um, we can say that rather than precipitation falling as snow, precipitation falling as rain is expected. The percentage of snow-covered area will decrease by up to 44%. The duration of snow on the ground will decrease around by 45 days. Snow water equivalent will decrease by 44% in the upstream and 67% in the downstream regions. And in melting periods, total flows feeding the basin are approximately 68% for the reference period, and this rate will decrease 60% in the future. And lastly, snowmelt timing will shift earlier by 14 days. So this may increase water stress in the late spring and summer in this region. That's all for today about my speech. So thank you so much. If you have any questions, please don't hesitate.
Thank you again for your presentation. It's very good. Just wanted the short question. You mentioned
Yeah.
that you used the climate index. You used the indices 17.
Yes.
Yeah.
Yes.
So all the indices as the climate variable, or just maybe you use the land and the other things.
No, no,
Mainly atmospheric and
the
the climate.
climate
Ah.
indices. Yeah.
Didn't you use the soil or land things or the?
Can you? Okay. Thank you. Actually, I can show what are they. Um, Sorry. You can see on the bottom. Generally, they are the climate indices.
Yeah. Okay. Thank you.
You're welcome. Thank you for your question.
Good afternoon. I am Can Tekin. Uh, I am a researcher at Atatürk Soil, Water and Agricultural Meteorology Research Institute. I will talk about the climate adaptation and mitigation research in agriculture, Turkey cases presentation today. We prepared this presentation with Dr. Tekeli. She is the coordinator of General Director of Agriculture Research and Politics in Climate Change. Let's move. As you know, Turkey is located on the crossroad in Europe and Asia. We call it the Eurasia shortly. And in the climate projection, Turkey is part of the southern belt on the Mediterranean Europe. Turkey is extremely vulnerable and to anticipated climate change impacts. What that means is water scarcity as a result of the climate change. And also, it can be observed that in winter time, estimated the temperature increase higher the eastern half of the country. In trend analysis, we can see this temperature increases and significantly important. Also, in summertime, this pattern is reversed at the western half of the country, especially in Asian region experiences temperature increase of the 6 Celsius degrees, and in the trend analysis we can see this increases also. Shortly, in general, presentation decreases along the Aegean and Mediterranean coasts and increases along the Black Sea coast of the Turkey. Central Anatolia shows the little or no change in precipitation. Okay, and I will talk about the agricultural land suffer from the shortage of rainfall. This is the result of the climate change. As you know, it affects the agriculture a lot. So it creates the drought. Drought increases most of the places in Turkey. Also, not just the increases, also frequency of the drought is increasing. It is necessary to develop, that's why it's necessary to develop the well-considered strategies deal with the food security and climate change. And also in this context, the main purpose is to ensure to sustainable and productive use of natural resources. Okay, I will continue to agriculture research system in Turkey. There is mainly 4 organizations. One of them is the Ministry of Agriculture of Forestry, and in General Director of Agriculture Research and Policy, we call the TEGEM shortly, and we have the 48 institutes to work the studies of the climate change, other research. Also, Minister of Industry and Technologies, the Scientific and Technological Research Council of Turkey, we shortly say TÜBİTAK. And another one is the universities and the faculties, agricultural faculty, veterinary faculty, also private sector and non-governmental organization. In the research organization, we have 3 deputy. Under one of the deputy, we have the departments. One of the departments is the field crops, horticulture crops, plant protection, animal health and food and feeds, also soil and water resource and biodiversity and others. We have under the 48 research institutes, these research institutes work these topics. And research areas, we have plant breeding agronomy. Also, we try to create the drought resistance plants and also the plant health, also livestock breeding and husbandry, also animal health, aquaculture and fisheries, food and feed, of course in the soil and water resource and biodiversity and agricultural economy. You can see in the research institutes in here, we have 48 research institutes. 10 of them is the central research institutes, 10 of them the regional research institutes, 28 subject-based research institutes. What does this mean? For example, in the West Coast, we grow a lot of the fig. We have the fig research institutes. Also, In the north part, we have the Hazelnut Research Institutes, like that. And we continue the mission of the game. We have two main goals. One of them is the research and development, others is the politics. In the research and development part, our goal is to increase the yield and quality, to develop the new crops and varieties, breeding stocks and technologies, also to protect and provide sustainable use of genetic and natural resources. Under the politics, our aim to prepare the alternative politic documents based on science for decision makers, also carrying out the impact of assessments of already implemented the policies. So, in the initiatives, present initiatives in the agriculture to increase the resilience sectors to climate change has been developed. One of them is the Agriculture Research Master Plan, of course, and I will talk about that. One of them is the title is the climate change. And also we have the Minister's Strategic Plan, also Agriculture Action Plan has been prepared. Work set up early warning monitoring system. Also work started to widely implementing the zero tillage, good farming practices and organic farming. I will talk about shortly a little bit about that. Programs started to implement studies for water saving irrigation technologies. Program improved the with plant atmosphere simulating model prediction using the climate scenarios. Also, and works on water harvesting, precision farming, soil carbon metering, and renewable energy. And I will talk about the agriculture research master plans. It will continue to 2025. We have mainly 5 main topics. One of them is the climate change, others is the sustainable use of natural resources, and other one is the information systems, climate change, agricultural drought and its impact, efficient water use. And I will talk about the climate change projection to estimate the yield decrease with climate change. In Hadley climate projection in 2050, 7 geographic region plus national market, 5 crops with barley, corn, sunflower, and cotton cover the 80% of the area sown, the main crops. The estimated yield decrease is the white and barley 7.5 degrees, corn is 10, cotton is 2.19, and sunflower 6.35 degrees. Also, I will talk about the shortly agriculture drought coordination councils. This come from bottom to up. In bottom, we have local area impact assessments committee, also data acquisition agencies and working groups that will gives the monitoring early warning committee, and other one is the risk assessments committee. All the data is collected and then go to agricultural drought council. So another studies about the ecological zones of Turkey. We in our GIS department, they create agriculture basin models has been formed in order to plan and increase the production while protecting natural resources and implementing an efficient and regional agriculture supports policy based on the agricultural basis. We use these basins. So in agricultural basins, within this scope, totally 30 agriculture basins have been identified through the evaluation of approximately 528 million data based on the soil, also topography, land classes, and land usage types. And for each basin, the strategic and specific supply deficits and competitive products have been selected. For example, in here, good agriculture practices. You can see the suitable areas for cherry. Green one is the suitable, red one is the not suitable areas. Another example for the mice, again, the green one is the suitable, red one is the not suitable areas. We created this maps. Also, another one project is support the farmers, improve the pressure irrigation system. 30 or 80% water saving we had. Also, the 40% of the saving the energy, 50% fertilizer, 30% saving the chemicals, and 20 and 50% the yield decrease we have. This is a primarily water and other inputs has been saved in largely. And also the present almost 400,000 hectares of land have been opened and irrigated by pressure system with use donation and credits. Deficit irrigation project have been implemented the support program. You can see in the picture these irrigation uh, systems. And also government's income support the farmers to improve the pressured irrigation system. The 60% discount in the interest of the credits given by Minister of Agriculture and Forestry through the Agriculture Bank is provided to farmers who will start to use the drip irrigation system. We supported the drip irrigation system because of the saved water, and this implementation brought is an zero interest of the credit for 5 years from beginning of the 2007. And you can see in here open channels and pipes. And again, open system convert to closed system. I mean, we try to use the pipes again, and that's why we we save the water because we decrease the evapotranspiration. So also we use the technology to increase the water use efficiency. For example, GIS and remote sensing, spectral reflectance, neutron probes, infrared thermometer, canopy temperature, and leaf water potential. And development improving varieties. Also, we try to create a high tolerance to abiotic stress like the drought, heat, cold, salinity. Also, high yield potential crops. Also, resistant and tolerance biotic stresses. And in for the wheats, also we use the other crops, for example, the rice. And as you, we have the plant drought tolerance test centers. These test centers within the body of Konya Bahri Dadaş International Research Institute in 2010. Mostly they work studies on the wheats. And this center is willing to cooperate with ICARDA and other international organizations work together. It is expected to, the center will support the food and security of the region. And water harvesting in drought and semi-drought regions. You can see in the picture, we try to catch the rainfall water and then use for the irrigation. The purpose of this research is investigate the effect of the volumetric soil moisture in different micro catchment water harvesting techniques. Sometimes, the water is, in runoff, and we cannot catch these waters. So using this soil harvesting technique, we can catch the water and then use the soil moisture. And effect of the different tillage methods in carbon emission. With this research, it was determined the most suitable soil tillage methods in terms of the carbon emissions and to bring the approach to change the tillage methods. And with this study, it was monitoring the effects of carbon emission during the whole vegetation proving periods, for example, sowing, irrigation, and spraying. It was determined the organic carbon changes in the soil, periodic changes of the carbon emission caused by seasonal change, and identify the lowest and highest carbon during the day. And in terms of sustainability, physical, chemical, and biological changes in the soil, especially organic carbon and microorganisms was demonstrates. Carbon emission difference found. This is also for our mitigation uh, studies. Another one is the studies to expand no-tillage cultivation in places where the precipitation lacking, the less water, soil moisture is tried to be conserved by no-tillage cultivation methods. And also in the interior regions of Turkey, where annual precipitation is below 450 millimeters, that means the drought areas, tillage cultivation and the follow practice being applied. Also, in order to expand knowledge practices, uh, our department carries out the training, extension, and demonstration studies. In addition, the General Director of Agriculture Enterprises applies no-tillage cultivation in large lands and demonstrates the practices farmers. I will continue a little bit climate change and agricultural soils. Soil productivity maps was created, and the productivity parameters of Turkish agricultural soils are updated and toxic element content determined. Another one is the fertilizer guides was prepared based on the research, and we increase our research about mineral and microbial fertilizer studies. Also, and farmers use this guidance for fertilizer activities. Another one is the soil carbon maps. The outcome of the project is to establish the natural geospatial topsoil soil fertility and potential fertilizer consumption information system for Turkey with reliable data and information the upper soil quality, fertility properties, soil organic carbon and chemical fertilizer uh, consumptions. And another project is investigation drip irrigation opportunities in rice and determined methane gas releases. As you know, the rice use a lot of water, and then we try to use the drip irrigation methods. That's why we save the water, and uh, we get the 22% of the yield loss, but we save the 70% of the water. That's why the drip irrigation can use in the rice, growing the rice. Also, in addition to these studies, we try to measure the greenhouse gases, especially methane release. We try to measure the methane release in these studies. Another study is sensitivity of winter wheat and sunflower crops in the climate change. And in this study, we increase the average temperature and average solar radiation. And then there's also the rain-fed condition, no irrigation. And then in these studies, we get the for wheat, if temperatures increasing, we can get the high yield of the wheat. However, for the sunflowers, we have the less yields. Another study is the effects of the soil split nitrogen fertilizer and application, nitrous oxide greenhouse gas emission. And the aim of the project is determined about the nitrous oxides gas released into atmosphere due to reaction of nitrogen fertilizer using the agriculture activities in soil condition and determine the soil moisture, temperature, and fertilizer to determine the relation between them, and use this chamber of these studies. As you can see, in the weight is high. Also, it's starting to growing. Uh, Another one is the climate change and livestock studies. production system and environmental impacts of greenhouse gas emission from animal production and manure management, and modeling studies of greenhouse gases originating from enteric and fertilizer-based animal production carried out. And also the studies are contained in cattle, sheep, goat, and chicken animal species for TF2 model, which is recommended by the IPCC and includes the condition of our country. And determining the climate change resilient agriculture produced in Turkey. In these studies, we used the FAO SHARP tool, and as you know, the Paris agreements for measured adaptation. All the countries gonna use this FAO SHARP tool. We already start in this project. We started a survey in this project in the farmers. And another one is the climate fluctuation effects on olive trees with the dendroclimatological research. And then this studies also we continue with the help of the diatrometers and climate sensors. The response of the olive trees to climate variability is monitoring in order to determine the olive physiology. With the help of the tree rings and carbon oxygen stable the isotope measurements, it will be possible to examine how olive to react to climate fluctuation in previous years. Also, at the end of the project, the objective is to develop methods to protect against the negative effects of the climate change for the olive trees, which is the characteristic of the plant of the Mediterranean basin. Another one is the Fatima project. These ones, 11 countries participated in these projects. Also, the project aims to develop the new tools and optimize the use of water and fertilizer for intense agriculture within the scope of adaptation and climate change. A WebGIS technology package was created combining observation of the tools, weather forecasts, and local observation that are combined to estimate the optimum irrigation schemes and fertilizer requirements for farmers. This is also a very good network for us to help and learn to each other. And climate change and biodiversity, we have two seed gene banks, also 18 land gene banks, 6 geophyte gene banks, also National Botanical Garden, 2 cells and tissue gene banks, National Food Starter culture gene banks, aqua products and gene banks, and we try to save our geophytes. Also renewable energy, we invest for the renewable energy, especially solar panels, and then we produce the renewable energy for irrigation systems. Also in the irrigation channel, we cover the irrigation channels with the panels, so we create the energy. Also we decrease the evapotranspiration on the channels. Another one is the Agriculture Energy Research Center. It was established within the body of the Black Sea Agriculture Research Center, using the residual materials and produce biodiesels. And we try to use precision farming systems. And another one about the climate change international project program. RID project on climate smart system is one of them. In this project, we subsoftware irrigation application for small stakeholders, cooperation, Turkey, Germany, African partners. Another one is the IRANET, ICT, Agri2, Information and Communication Technologies, and Robotics for Sustainable Agriculture. This is the 7th framework program. Another one is the FAO GFE, Developing the Monitoring and Evaluation for the Natural Action Program for combining the desertification and land degradation. Aranat, Eregas, Susan, and ICT Agri2, another was the international program. And thank you for attention. Any questions? Okay. Thank you.